There are a couple different versions of factoring, and the first is the greatest common factor. When you see problems that have a number in common or a letter in common, we always want to take out that greatest common factor first. So in the first example, both terms have a factor of 2 and they both have an x. So we'll take out a 2x and we'll fill in the parentheses of what else needs to be multiplied by 2x to get back to the original so that they are equivalent. So 2x times another x would create the 2x squared, and 2x times a subtraction of 10 would multiply to make the negative 20x. And that's the factored form. On the second one, similarly, all three of the terms have a common factor of divisible by 5, but not all three have x. So we'll take out a factor of 5 and fill in the multiplication. 5 times an x squared would make the original. 5 times a minus 8x would get back to negative 40, and 5 times a positive 2 would create multiplication of negative 10. So that's greatest common factor. The second type of factoring is when we have three different terms that have no greatest common factor. Here we're going to try to come up with some sort of multiplication that will create this values when the first coefficient of x is a 1. So what we do first is we think that when we distribute, an x times an x would distribute to make x squared first. To multiply to get 12, we know that 12 is 3 times 4, or 6 times 2. If we do 3 times 4, then when we finish distributing, x squared, x times 4 would make plus 4x. Distribute the 3, 3x, and 3 times 4 is 12. Combining like terms in the middle would create x squared plus 7x plus 12, which is incorrect. So 3 and 4 was not the right choice. Instead, we should have chosen the 6 and 8. So if we try again, x times x makes the first x squared, and the end, 12, is 6 times 2. And now if we redistribute each time, x squared plus 2x plus 6x plus 12. And combining like terms in the middle, x squared plus 8x plus 12. So this one is the correct form of factoring, problem A. What we do is we tell ourselves what numbers multiply to the end, multiply to 12, but what two numbers would also add in the middle to combine like terms to make the 8. If we look at the second example, x squared plus 5x plus 6. When we break it apart, x times x multiplies to x squared, and 6 is 6 times 1, or 2 times 3. But 6 and 1 don't add up to 5, so we must pick the 2 and 3, because 2 plus 3 would add to 5, but multiply to 6. Example C. What multiplies to negative 18? 9 and 2, or 3 and 6? And 9 and 2 can somehow be combined to make negative 7. So if we put in 9 and 2, we would need a negative 9 and a positive 2 to multiply to negative 7, but add to negative, or sorry, I said that backwards. To multiply to negative 18, but add up to negative 7. And the last one. Now the first coefficient in front of the x squared is a 2, not a 1x squared. So we must take out the greatest common factor first. Take a 2 out of every piece, x squared plus 2x minus 15, and then factor the remaining part. There was a 2, and then we'll break up the inside. To get x squared is x and x. To get minus 15, we need a 5 times a 3, and to add up to positive 2, we'd want a positive 5 and a negative 3. And there is our final factored form. So part D had 2 steps. The last kind of factoring that we will talk about is factoring when there is a number in front of the x squared, but it's not a greatest common factor for each part. This one is the trickiest steps of all, because when we factor, our answer has to somehow have to multiply to 2x squared. So we need a 2x and an x. But guessing and checking those last numbers is a lot of work. So instead we're going to use a several step method. What we'll do is we'll take the first number and the second number, multiply those together. So just as a side note, 2 times 12 is 24. So we're looking for numbers that will multiply to 24, but add to 11 in the middle as we combine like terms. So if we think of numbers that multiply 24, 8 and 3 are the two that will multiply to 24 but add to 11. So here's the trick. We're going to uncombine the like terms in the middle and keep everything else the same. So we'll keep the 2x squared and the plus 12, but instead of having combined to 11x, we'll keep them separate, 8x plus 3x. From here, we're going to split our problem in half and take out the greatest common factor on each side. So on the left-hand side, both terms have a factor of 2x, and we'll fill in the distributing. 2x times another x would get back to the original 2x squared, and 2x times plus 4 would get back to the 8. Same thing on the other side. Take out the common factor between 3x and 12, which is 3, and then we need x, and 3 times positive 4 would get back to the 12. What you'll notice is both sides have an x plus 4. That's the common factor between both sides. So our final answer is a common factor of x plus 4, and then what that x plus 4 was multiplied by. For one side, it was the 2x, and for the other side, it was a positive 3. You would never believe this. This is the final answer, and we could double check by doing the distributing. X times 2x is 2x squared, plus 3x, 4 would be plus 8x, and then 4 times 3 is plus 12. And if you combine your like terms, it does get us back to our original. So we have a final factored form. Let's try one more example just like these to solidify and clarify any questions. Last example. The first step we want to do is multiply our first number and last number to see what our two choice numbers should multiply to. So 3 times negative 7 is negative 21. So we need two numbers that multiply to negative 21, but add to 4. Negative 21 is 3 times 7, but we need to get to 4. So one of them must be negative. Minus 3 and a positive 7 would make 4 and negative 21. We'll replace that into the middle as if we're uncombining the like terms. 3x squared and minus 7, but change the 4x to be a negative 3x and a plus 7x. From there, we split our problem in half and take out the common factors. The first left side, both terms have a 3x, and 3x times x to get to x squared, and 3x times a minus 1 to get back to 3x. Second side, both terms have a 7, and then 7 times x, and 7 times minus 1. Again, you'll notice how both sides have the same in common term, so that's one part of our answer, x minus 1. And then we also need what they are multiplied by. In this case, it would be a 3x for the first plus a positive 7 for the second. And our final answer is x minus 1 times 3x plus 7.